Assalamu alaikum. Hope that everyone will be fine. In this lecture we will discuss about the moment distribution method. In last lecture we discussed about the first example about the moment distribution method, in which we talked about the same beam, but the only modification in this example there is a rocker or roller support at point C. In last example there was a fixed support at point C. So by changing any support, the whole procedure will be changed for the moment distribution method. So the detailing of the question is 240 pound per feet is the load intensity for BC span, and the length of a BC span is 20 feet. For AB span is 15 feet. Moment of inertia of AB is 300 inch raised to the power 4, and the moment of BC span is 600 inch to the power 4. So in this lecture the aim is to find the internal response of the beam. So the first step of the moment distribution method is to calculate the stiffnesses. So for each member means the stiffness of AB, BA, BC and CB. So we require the 4 stiffnesses for calculating the distribution factor, and in last the aim is to find the internal response, or we will draw the SFD and BMD for the given beam. So the first we will calculate the stiffness of AB. So stiffness of AB will equal to infinity because the moment carrying capacity of A is infinite. So the distribution factor for AB will equal to 0. Now we will find the stiffness for BA span, means from the B side we will calculate the stiffness. So KBA is equal to, by using the flexural stiffness formula, for EI by L. So we will calculate the stiffness for BA. E is the elastic modulus, I is the moment of inertia of that span, and L is the length of AB span. So putting the values, we will get the value of KBA, means the stiffness for BA. Now we will calculate the stiffness for BC span. So we will use the same formula for EI by L. E is the elastic modulus, I is the moment of inertia, L is the length for that span. So putting the values, we will get the stiffness for BC. Now in last we will calculate the stiffness for CB from C point. So we will use the same flexural stiffness formula for EI by L. Putting the values, we will get the stiffness for CB. Now we will calculate the distribution factor from stiffnesses. We will calculate the distribution factor. Distribution factor for AB will equal to 0. Remember this, at point C, when there is a fixed support, the distribution factor will equal to 1. When there is a roller or hinge support, the stiffness will be equal to 1. When there is a fixed support, the stiffnesses will equal to 0. Remember this, because this form are 1 by infinity form, which equal to 0. So the distribution factor for AB will be equal to 0. Now the distribution factor for AB can be calculated by the basic formula of distribution factor. The basic formula of distribution factor is equal to stiffness of a member divided by the total stiffness. So we will calculate the stiffness of AB. So we will calculate the distribution factor for BA. So DF BA is equal to stiffness of BA divided by total stiffness at point B. Since there is a 2 member attached at point B, at joint B, so we will add in denominator 2 members stiffnesses. So KBA, distribution factor for BA will be equal to substituting the value of KBA divided by stiffness of BA and BC. We will get the distribution factor for BA, so which will be 0.4. Since we did the same example in last lecture, so we will put the distribution factor for BA is 0.4. Now the same method will be for BC. So distribution factor for BC will be equal to the stiffness of BC divided by total stiffness at point B. So we will get the value of a distribution factor for BC is 0.6. At point C there is a roller support or hinge support. For this the distribution factor will be equal to 1. So by putting the same formula, distribution factor for CB, which will be equal to the stiffness at CB divided by total stiffness at C. So the total stiffness will also be the KCB. There is attached only one member at point C. So by putting the values we will get the distribution factor for CB is equal to 1. Remember this, for fixed support the distribution factor will be equal to 0, and for hinge or roller or rocker support the distribution factor will be equal to 1. Now for the distribution factor, make a table for different iterations. So the table will be in the form of rows and column. In the first row will be the joint, and the second row represent the member, third row represent the distribution factor as we calculated by distribution factor formulas. So the fourth row will be fixed end moment. Remember this, separate the fixed end moment and distribution moment. So the fourth row is fixed end moment and the fifth row is distribution moment. So these 5 row are same for any example. Now the sixth row will be carry over moment. We will carry the moment to the members by distribution factor, and the sixth row is again distribution moment. So we will stop the iteration when the moments at any end at any joint will in the form of 0.0 something and 0.4, or the allowable limit is around 0.5. we will stop the iterations or successive trial. So this is a table for the moment distribution method. So understand this table. The first row will be the joint, second is member, and the third is distribution factor, fourth is fixed end moment. We will calculate the fixed end moment for each members, and distribution moment and carryover distribution we will repeat until we get the moments at each joint in the form of 0.5, 0.4. So we will start the trial. So first we will make a row of joint. So there is a 3 joint A, B and C. At each joint there is a member attached to a joint. So the second row is a member. At joint A there is only one member is attached, AB. At joint B 2 members are attached at point B. So this is a point B. The one member is BA and the second is BC are attached at point B. So in the joint B column we will make a 2 more column of BA and BC, member BA and BC. At joint C, the last joint, there is only one member attached, which is CB. So the third row is a distribution factor. So the distribution factor for AB will equal to 0, as we calculate that the distribution factor for fixed support is 0, and the distribution factor for BA is 0.4, distribution factor for BC is 0.6, and the distribution factor for CB or roller or rocker support or hinge support is 1. So this is the third step. Now the fourth step is to calculate the fixed end moments. Fixed end moment for KBA means there is a moment and there is a moment. The unlocking and locking phenomena will be used as for the definition of a moment distribution method. So we will calculate this is a member A, this is a member B. We will calculate the fixed end moment AB and BA. AB and BA by using the formulas as mentioned in books. So fixed end moment of AB and fixed end moment of BA. So there is no external load, so the fixed end moment for AB and BA will equal to 0. So the fixed end moment will be equal to 0. Now the fixed end moment for BC span means this is a B and this is a C. There is a UDN intensity of 240 pound per feet. So by calculating, this is a B and it is a C, so fixed end moment for both sides, we will get the fixed end moment which is by using the formula of WL square divided by 12. For anti-clockwise we will take the negative sign, for clockwise we will take the positive sign. By putting the value 240 instead of W, and L is the spin length, which is 20 square divided by 12. So we will get the fixed end moment for BC is minus 8000 and for CB is plus 8000. Now we will distribute the moment. Now for distribution moment, we will multiply the net moment to the distribution factor for the respective member. So for B joint, the net distribution will be 0 plus minus 8000, which is the moment. So the net will become equal to the minus 8000. So take the opposite sign value. So the total moment is minus 8000, so the opposite of minus 8000 will be plus 8000. So this plus 8000 will be used for calculation. This is the step for the distribution moment, how we will distribute the moment by multiplying to the carry over factor. So distribution factor. So the first step is adjoint take the net moment, which is minus 8000. So take the opposite value of minus 8000, which is the plus 8000. So multiply plus 8000 to the 0.4. So the value will be 3200. So write in BA, this in front of BA member or column. So the same plus 8000 multiply the plus 8000 to the distribution factor for BC. So the moment will be 4800. This is the procedure for distributing the moment. First we will calculate fixed end moment, then for distribution moment, first is to take or find the net moment at point 8 joint B, then take the opposite value. By taking the opposite value, then multiply for B and BC, means distribution factor of B and BC. The moment we get we will write in the column of BA and BC. So for plus 8000, the net is plus 8000, and by net means add the moment, total moment. So there is only one moment, so then the net will also be is plus 8000. So take the opposite value of this net moment, which is plus 8000. The opposite will be minus 8000. So multiply this opposite moment to the distribution factor of joint C. So we will get the minus 8000. So minus 8000 multiplied by 1, we will get the same value. So write in the distribution moment row all the values. This is the this is the calculation of first step by distributing the fixed end moment at each member by the amount of stiffness distribution factor. So the distribution factor is very important. It implies that by what percent it takes the moment. So by in this method, in this procedure, we will distribute the moments. So the second is, now we will carry over the moment, means we will transfer the moment by half amount to the each joint. Remember this, since now you by seeing the distribution moment, so there is a 3200, so distribute this moment by half. Since the distribution carryover factor is 0.2 1 by 2 or 0.5, so divide this moment by 1 by 2, so we will get the 1600. So this is the distribution carryover moment. So this is a 1600, which will from B joint it will shift to the A joint. Remember this, the moment will transfer from B to A to B, B to C, and C to B. Remember this is the procedure by carry overing the moments. Now for BC, see the moment at BC span. So from BC span the moment will shift to this CB span. So for what amount? By 1/2 factor. So we will multiply the moment 4800 to the 1/2, we will get the 2400. So we will distribute this, carry over this moment 8 point CB member, 8 point C. Remember, this is the fixed moment and distribution. After distribution we will carry the distribution moment at each joint. So now we will get the distribution carryover moments, which is 1600 8 point A. 8 point BC member is minus 4000, and for BC there is a 2400. How we get this? Since from C we will also carry over moment to the B point. So remember this 8 point C, there is a distribution moment is a minus 8000. So carry over this moment by half, will transfer at BC span, so minus 4000. So we will get the distribution carry over moments. Now we again distribute this carry over moments at each members. So there is a 1600 moment, carry over moment 8 point A. So the opposite of this moment is minus 1600. So multiply this minus 1600 to the distribution factor, we will get the zero distribution moment. Zero distribution moment. Remember this. How we will get? Take the opposite and multiply to the distribution factor of the respective joint. Now in this the net will be minus 4000. Take the opposite value, which is plus 4000. So multiply plus 4000 to the 0.4, we will get the 1600, and plus 4000 to the 0.6, we will get 2400. This is a distribution moment. So in the joint C there is a moment of 2400. So multiply, so take the opposite value, which is a minus 2400, and multiply this with distribution factor. So minus 1 multiply minus 2400 multiply by 1, we will get the minus 2400. So now again we will distribute this distribution moment. So 8 point A, there is a zero distribution moment. 8 point B, BA is 8 member BA is 1600, member B is 2400, and member CB is minus 2400. Now we will carry over this moment to the joint A, B and C respectively. So from B joint the moment will shift to the A joint by half. So half of the moment will transfer to the A joint. So take the half of this 1600 is 800. So 800 will be the carryover moment at joint A, and there is a distribution moment is 0. So take this half of 0, which is again 0. So the distribution factor carryover moment will be for BA will be equal to 0. Remember this. And again we will distribute this 2400. We will carry the distribution moment to the joint C. So take the divide by 2 this 2400, we will get the 1200 at joint C. This will carry over to the half of the moment from B to shift will B to C. So we will get the 1200. From C the half of the moment will transfer 8 point B. So minus 2400, the half of the minus 2400 is minus 1200. So this is the carry over moments. Now again distribute this carry over moment to the each joint. So by so 800 minus 1200 and plus 1200. So minus 800, the opposite of minus 800 is for distribution factor, distribution moment. We will take the opposite value and multiply with the corresponding distribution factor. So the opposite of plus 800 is minus 800. So multiply with distribution factor, we again receive 0 distribution moment. Now take this minus 1200. So the opposite of minus 1200 is plus 1200. So plus 1200 multiplied by distribution factor, so we will get the 480, and plus 1200 multiplied by this distribution factor, we will get 720, and opposite of this carryover moment is minus 1200, so multiply minus 1200 to the distribution factor, which is 1, so we will get minus 1200. So repeat these all procedure for each joint until we get the 0.4, 0.24, 0.6 or 0.5. So in the form of 0.5, in the form of 0.6, in the form of 0.4, not more than 0.6. Remember this. If this occurs 0.7, then make one trial more. So we will get the total moments. So this is the step for how we will distribute the moment, how we will carry over the moment. Distribute, carry over. So this procedure we will repeat until we get the values in the form of 0. something. So 0.6, 0.5, 0.4. So the last step is to add all the moments. Remember this. This is a fixed moment, distribution moment, add all these moments. So we will get the moment at point A is 2823. So add all the moments. For BA we will get 5647, and add all moments, sum up all the moments. For BC we will get opposite of this value, minus 5647, and add all these moments, we will get the 0. So at point P there is a fixed support, so fixed support has moment carrying capacity, so 2823 keep feet or pound feet will be the answer for moment AB. For moment BA there will be a clockwise moment 5647, and for BC there will be anti-clockwise moment minus 5647. These both value are same due to at point C there is a roller support. At roller support the net moment will be equal to 0. So when we add these both values we will get the 0 moment. So add all these moments for AB. For AB add all these moments beside distribution factor, so we will get the value of 2823, and for BA add all the moments, we will get 5647. For BC add all the moments minus 5647. So the net moment at point B will be equal to 0 because there is a roller support. The total moment at roller support will be equal to 1. So when we add we will get the 0, and total moments or the moment at point C will be equal to 0. By adding all these moments we will get the 0 value. If we can't get the value at point C is 0, so there is an error in calculation. So we calculate the moment AB, moment BC, moment BA, and moment CB. The moment of AB is 2823, and the moment at point C is 0, and these both moments are equal 5647 and opposite. By calculating the moments, now the structure will be determined. So take this joint and apply the equilibrium equation. We will find the VB from left side, means this reaction from left side, and take the other take this span section BC and apply VB right. It means the shear at point B from the right side. So we will get the value for VBL and VBR. So for BY simply add VBL from left side the shear and from right side the shear. We will get the value of BY. By achieving the value of BY, now calculate by using equilibrium equation. We will get the support reaction at C, reaction at A. So by simply drawing the shear force diagram and bending moment diagram, this is the whole procedure for this kind of beam. In this example, the only thing is important is this table. So remember this, how we will distribute the moment, how we will carry over the moment. Remember this, in distributing the moment, we will take the net moment at the point or the member and take the opposite value and multiply with the corresponding distribution factor. We will get the distribution moment. For carry over, by simply half the value, means from B side the few moment will transfer to the BA, and from A side moment, half of the moment will transfer to the B. From B to C, half of the moment will transfer to C, and half of the moment will transfer to B. Means by what amount, by what factor? By half of the moment will transfer. So this is the whole procedure for the moment distribution method. So hope you got and you understand. So take care of yourself. Allah Hafiz.